Today is the 20th of May 2024, and this will be our fourth revised probability session. Okay, the only difference is I'm adding a bit more. Okay, and I think the only difference is I'm adding a bit more. Okay, thank you to all my subscribers. Okay, please subscribe, like, share, follow. Okay, if it's not going to cost you, I know that on some platform, if you subscribe, you have to pay. So they say follow, the follow aspect. The follow aspect is free. Okay, some of them, the subscriptions are free. So please subscribe. Okay. If the account is not yours, please ask permission from the account holder. Okay. It's very good thing to do. Don't take people's stuff and use it anyhow. And then when it's broke, you say, oh, I'm sorry. No, we don't live like that. Okay. Thank you to and if you want, just open your own account, okay, to help you and it to give you peace of mind, and then use it to subscribe, and then when I upload, you get yours. Okay, in the comment section you always see follow my no/script. Okay, on and off, at times I have to catch my breath and stuff, so at times I can't explain it. It's just a mouth can be a mouthful sometimes, and a lot of numbers. So it does happen. You want to say 52 and then you end up saying 53. Okay, so just follow my no/script. I appreciate it. If we're interactive, somebody will say, oh, no, or that, but it's not, at the moment it's not. Okay, so please, just follow my no/script. You always see that in the comment section. Beware of scammers. Okay, I watch a few once a while. I watch some a comment, and it seems the scammers are everywhere. Okay, please, if I haven't said it and you fall victim to it under this platform, then it's my fault. But I'm trying to tell you, there are scammers out there, so don't give in to them. I've told you, it's not that I don't like doing charity work. I give to charity, but at the moment, this platform is not collecting money from any charity. Okay, no charity has asked me to do anything like that. Okay, so please do not fall for it. If a charity asks me to do that, then I'll let them record what they want, and then I'll upload it on this page for you. Okay, but if you haven't seen anything like that, and I'll say it to you before I upload it, so it's not just like they record something and then I put it on my page. I'll say that in one of my videos so you are aware, and then I'll show you. But I haven't done anything like that. So if people are coming to your inbox under this platform, please don't fall for it. whether it's WhatsApp or Messenger or whatever. Don't do that. Don't fall for it. Recap. Watch the last video for your recap. Okay, we are doing revision on probability. We've looked at dependent events. Okay, where you pick one, you do not replace. Okay, and then you pick another one, you do not replace, and then we are finding probability of those. We started by looking at the OR law, which we've looked a lot of that before mutually exclusive event. Then we started looking at the end law, where you pick two things like this at the same time. For instance, your probability of getting two ones on a throw of two dice. Okay, two dresses, two same colored dresses. When you pick two dresses from the box, okay, and then we look at events. When you are going in, you pick, you do not replace. Okay, and that is what we are looking at. So let's start with the mental mass, and then I'll show you what I have for you today. Okay, now mental mass. Okay, simplify all of that. Okay, so the root of 200, you can write this as the root of 25 times the root of 8. Root 25 is 5. Root 8 is root 4 times root 2. Root 4 is 2. So you have 5 times 2 times root 2, which will give you 10 root 2. Root 50, the second one here. So root 50 is the same as root 25 times root 2. Root 25 again is 5 root 2. Okay, that one. So we simplify. 3. Root 12, which is root 4 times root 3. Root 4 is 2 root 3. 4. Root 24 times root 4. Okay, so root 6 times root 4. Okay, if I do it as root 8 times root 3, I have to come back to root 24. So I rather do root 6 times root 4. Root 4 is 2, so I have 2 root 6. Root 48, which equals to root 12 times root 4. Root 4 now here is 2. Root 12 again is root 3 times root 4. Okay, so I have 2 times 2 for root 4, or root 4 times root 4 is 4. So I have 2 times 2 times root 3, which is 4 root 3, or root 4, which will be 4 root 3. So whichever way you look at it, you will get to your answer here, 4 root 3. Root 98. Okay, you can have it as root 49 times root 2. So root 49 is 7 root 2. Okay, that is why I said you have to be good at your times table. 243 is the same as root 27 times root 9. Root 27 is 3 times 9 times your root 9. Root 9 is 9 root 3. Okay, so we simplified root 243 to 9 root 3. Now today, our revised session of our probability. Okay, you are going to write especially the higher people. So it's good I discuss about this with you in case any of them come. Okay, assuming you have 10 colored cubes, okay, in a box. Okay, so this is your box, 3 red and 7 blue. Okay, the probability of picking a red would be 3 over 10. The probability of picking a blue is 7 over 10. Okay, now let's see what you do here. You have removed one cube at random from your box and note the color, but you do not replace it. You then repeat the process for 2 more. So you went in, picked the first one, you so you went in. Sorry for that pause. Okay, you went in, you picked the first one, you didn't replace, you noted the color, and then you went back in, picked the second one, no replacement, you noted the color. Okay, and then you went in, picked the third one. Okay, so let's look at the question. Find the probability. Okay, find the probability. So here you pick no replacement. Okay, of you selecting the cubes in the order given. Okay, now initially, if you have 3 red and 10 overall, then you are going to have the probability of picking a red is 3 out of 10. If you have 7 blue, the probability of picking a blue with before you even start is 7 out of 10. Okay, now here you are asked to find the probability of 3 red picks. So you go in first, pick a red, and then you note the color, you do not replace. You go in second, pick another red, you know the color, you do not replace, and then you go back in, pick a red, you know the color, and then it's a red. Okay, how do you go about it? So probability of you picking 3 reds, 1 red at a time, and no replacement, is you have to first pick the first red and the second red and the third red. Okay, this is the difference between the or and the end rule. So immediately you identify that the end law comes in. So the first one is 3 out of 10. You know the color. So now you have 2 reds and then you have a total of 9. So the second one will be 2 out of 9. You know that color. So now the red reduces again. And you have a total of 8. 1 over 8. Okay. So if you simplify, you can multiply the numerators and multiply the denominators. So you have 6 divided by 120, because 9 8 is 72, times 10, which is 720. Or you can cancel out. How many 2's do we have in 2? 1. How many 2's do we have in 8? 4. How many 3's do we have in a 3? 1. How many 3 do we have in 9? 3. So now in the numerator, you have 1. 3 times 4, which is 12, times 10, which is 120. So you can either multiply the numerator and the denominator and get 6 out of 720 and reduce further, okay? Or, so you cancel this, which will give you 120, okay? Or you cancel from here and you get 120, 1 over 120. B, what is the probability of first red, second red, and third blue? Okay, so the probability of the first red is 3 out of 10 times you didn't replace, so now you have 2 reds over a total of 9, so 2 over 9. And then the first blue, because now there are 7 blues, so 7 out of 8, okay? Or you've already picked the first 2. So the 10 in the box becomes 8, okay? So now here you go, okay? So now, how many 3's? You can multiply the numerator and the denominator, or you simplify. If it's a non-calculator paper, I would like you to simplify here. So how many 2's do we have in 8? 4. How many 3's do we have in 9? 3. So, and then the numerator is 1 and 1. So times 7. And then the denominator is 3 times 4 times 10, which is 120. Now, the probability of picking the first red and the second blue and the third red, okay? So the first blue, there are 7 blue in total. You start with 10, okay? So it's 7 out of 10. You know that it's a blue, so the second pick will now be 6 out of 9. Because now you have a total of 9, but you have 7 blue cubes, so 6 out of 9. And then the third will be red, so you have 3 reds, and then 8 in total, so 3 out of 8. And because you are not replacing, so you pick the first blue and the second blue and the third red. So you have to multiply now. Okay. Now, how many 6 do you have? How many 3's do you have in a 6? Is 2. How many 3's do you have in a 9? 3. Now these 2 here, how many 2's do you have in 2? 1. How many 2 do you have in 8? 4. Okay. So now you have 7 in the numerator and then divided by 40. So your probability will be 7 out of 40. probability of blue and blue, first blue, second blue, and third blue. Okay, you want to find the so you have 7 blue over a total of 10. Okay, so you start with 10. So if you go for the second blue, now you have 6 because you are not replacing. 6 over 9, and the third blue will be 5 over 8. So now, if it's a calculator, you can add the numerator and the denominator, and then maybe you find the answer in a decimal. But here we have, so how many 5s do we have in 10? 2. So 5 divided by 5 is 1 here. How many 3s do we have in 6 to 2? Okay, and then how many 6 do we have in 9? How many 3s do we have in 9? 3. How many 3s we have in 6? 2. Okay. I'm looking at it again. So 5 divided by 10 is 2. So 2 will cancel out, and then we have 3. 3 will cancel 9, and we have 3 here. So it's right. So we have 7. 3 times 24, so over 24. Example. So this one will be 7 out of 24. Again, we are using the AND law. Example. Monica has 9 colored counters in a bag. Monica removes a counter at random and does not replace it. Okay, so she has 9, 4 blacks, 2 red, and 3 blue. If you add it, it's 9. To get a pick of a black, 4 over 9. A pick of a red is 2 over 9. And a pick of a blue is 3 over 9. Okay. These ones is simple. Okay. Everybody, even the foundation student, by now, you should know this. Even if they guess ask you up to this point, what is the probability of picking a black? You should be able to say 4 out of 9. What is the probability of picking a red? 2 out of 9. What is the probability of picking a blue? 3 out of 9. Okay. Monica repeats 2 more and she doesn't replace it. Okay. So let's see what happens when she doesn't replace. Okay. What the probability I said earlier is if there is a replacement. Now, she picks 3 blacks. So the first is a black, and a second black, and a third black. Okay. Now, there are 4 blacks in the bag, and she has 9 of them. So the first one is 4 over 9. She notes it, and then she has 8 and 3 blacks. So the next probably to be 3 over 8. And the next will be 2 over 7. But because it's a black and a black and a black, it's 4 over 9 times 3 over 8 times 2 over 7. Okay. So here again, how many threes do we have in a 3? 1. How many threes do we have in a 9? 3. How many fours do we have in 4? 1. How many 4 do we have in 8? 2. Okay, and these 2 and 2 also cancel out. Okay, so this 4 and this 2 will cancel out this 8. Okay, to make it easy for you to see. So now you have 1 in the numerator. 3 times 7 is 21. So that will be our probability. Now, what is the probability of a first red, a second red, and a third blue? So the first red will be 2 out of 9. The second red, because you have only 2 reds, the second red will be 1 out of 8. And then the third blue, we have 3 blues, 3 out of 7. So now here again, it's guess calculation now. Okay. So 2 into 2 is 1. 2 into 8 is 4. 3 into 3 is 1. 3 into 9 is 3. So we have 1 divided by 3 times 4, which is 12, times 7, which is 84. Now see, first blue, second black, third red. Okay, so first blue, we have 3 blues, so 3 out of 9. Second black, 4 black, so 4 out of 8. We are not replacing. Third red, we have 2 reds, so 2 out of 7. Okay, so if we reduce it, how many 3s do we have in 3? 1. How many 3s do we have in 9? 3. 4 and 2 will cancel out the 8. Okay, so we have 1. 7, 3 times 7 is 21. Please, this is 7. Okay, that one here is 7. This one. So our probability to be 1 out of 21. Sorry, 1 out of 21. Yeah, I got that right. Now, under this question, blue, first blue, second blue, and third blue. So 3 out of 9 times 2 out of 8 times 1 out of 7. So if we reduce it, okay, how many 3s do we have in 3? 1. How many 3s do we have in 9? 3. How many 2s do we have in 2? 1. How many 2s do we have in 8? 4. So it's 1. 12 times 7 is 84. So 1 out of 84. Example, combination of and or rule. Okay, so I wanted to throw this quickly in here so that we'll look at it tomorrow properly. Okay, so it's just a quick one where you use the and and the or. So you multiply and then you add, and I'll show you how to do it. Just an intro, and then we'll look at it in our next video. Okay. Assuming you find a bag with 10 colored sweets, 3 sweets red, 7 sweets blue. You remove a sweet at random and note the color. Okay, no replacement. Then you remove a second sweet at random. Okay, also no replacement. Find the probability of you selecting a red and a blue sweet in any order. So here, instead of what we've been doing, you can go in and select a red and a blue, which is one scenario, or a blue and a red. They said no order. Okay, so this is where it comes to play. So you can go in and select a red and a blue first, or you can have a blue and a red. Okay, so a red will give you 3 out of 10. A blue will give you 7 out of 9. Here you are not replacing it. So a red and a blue being the first order will be this. Or you can go in and select a blue and a red. At the end of the day, you want red and blue. So whether you pick the blue first or the red first or the blue second or the red second, they have given you the freedom here. They don't mind the order. But as you're calculating, you have to think about the order. Okay, so that is why you go for, if you go for a red and a blue, you multiply and then you add another instance where you can go in and pick a blue and a red. Okay, so a red and a blue will give you 3 out of the 10. A red times 7 out of 9. And then a blue and a red will give you 7 out of 10 times 3 out of 9. But because they haven't specified any order, you can either go and pick this as your first instance, or you pick that. So this is where you include the and and the or law. Okay, so here if you reduce, 3 into 9 is 3. So you have 1 times 7 divided by 30. That will be your numerator. Plus 7 over 10, 3 over 9. 3 into 9 here again is 3. So 7 over 30. Okay, so here you have 1 times 7 divided by 10 times 3 plus 7, which is 30, plus 7 over 30. So you add the numerator since the denominators are the same. So you have 14 divided by 30, which you can reduce further, which will give you 7 out of 15. Okay, or you can leave your answer like this. So you can either have it and get 7 over 15 or 14 over 30. Okay, We'll look at more of these examples tomorrow. Okay. Please subscribe, like, share, follow. Please follow my notes script. If you need an account, open one. Okay. Or ask permission from the account holder before you use the account to subscribe. Beware of scammers. Take care of yourself online. Okay. Thank you so much for joining me today to watch this video, and I'll see you in the next.